All right, this lesson 115, unfortunately I made notes on paper that I'd rather you not. So if you printed out these notes, they don't have a graph, unless you want to cut out graph paper and put it on here. I want these graphed, so on very nicely on a grid, okay? So it might be easier to just get a piece of paper out and do what I did, and get your coordinate plane ready and labeled and set it up like this, okay? So what I would say do is write down example 1, make a grid, and so pause me, write down this and make a grid, and then we'll go ahead and graph it together. So now I'm assuming you already did that. You paused and then have this here, and we're going to graph it. Now we graph these just as if we were graphing the line y equals negative x plus 2, and then we're going to change things around. So if we were graphing, I'm just going to write it over here, y equals negative x plus 2. This is in mx plus b form, so I hope you remember this, super important. Number 2 is where it crosses our y-axis, so it goes through here. Here's a dot, and it has a slope of negative 1. Since there's no 1 there, or there's no number in front of x, we know it's negative 1. So it means it's going downhill, and it has a slope of up 1 over 1. Up 1 over 1. Now I really need you all to have a straight edge to do this the right way. Alright, so there it is dotted, right? Now before I go ahead and draw a solid line there, like I was graphing that, I'm going to stop and I'm going to look. Okay, remember how we used open circles when we had the non-inclusive, you know, this is greater than but not or equal to? If we had an or equal to sign here, it would be a solid circle on a number line. Well, just like that, instead of doing a solid line, we are going to graph a dotted line. And just kind of go pick up your pencil as you go. Okay, so there's my dotted line, and I'm going to go ahead and give it an arrow. All right, so we're almost there. We have most of our work done. Now what we are doing is graphing all the points that satisfy this, all of the ordered pairs that would work. What that means is we're going to shade in either side of this line. We're either going to shade in up here, or we're going to shade in down here. Now the way we decide is we pick a point and see which one works. So I'm going to go ahead and pick this point. How about 0, 0, because working with zeros is always nice. Okay, so I'm going to go ahead and try the point 0, 0 and see how that works. Okay, so that would mean, and we're going to see if this is a true statement or a false statement. Is 0 less than negative 0 plus 2? Oh, sorry, 0 greater than negative 0 plus 2. So let's simplify that. Is 0 greater than 2? It is not. So that means this point is not part of the solution set. Okay, I actually now wishing I hadn't written right here, because if that probably means I'm going to shade up here. So maybe I'll just shade around my work there. So let's try another point on the other side of the line. Usually though, once I know this side is false, this is going to work. So I'm just going to go ahead and try it though. I'm going to just to show you.
My camera's down there.
Okay.
I'm squeezing the foot.
I know. So let's try the point 2, 2. Alright, so that would mean is 2 greater than or equal to negative 2 plus 2? And it looks like 2 is greater than 0, so that is true. This was false. So if that's true, this this point is in the solution set. So this was true. So here is our final answer. When you look in the back of the book, you're going to see a quadrant shaded, or an area shaded on your coordinate plane. Okay, I just shaded around there, but that now tells us all the points above this line, and not including this line, are all part of the solution. Okay, let's try that again with the next one. Again, just like graphing y equals 2x minus 1, let's find that line. And I see it's an inclusive or equal to. So it's going to be a solid line. So here's my y-intercept, and our slope is 2. So we go up 2 over 1. It's a positive 2, so up 2 over 1, up 2 over 1. I'm going to go ahead and graph it. Nice and neat with a straight edge, please. Alright, we go like that. There it is. And now let's pick a point. Again, I always pick 0, 0 because it's easy. 0, 0. Let's see, am I still on the paper? Yes. 0, 0. Is this going to be true? Now, many of you can do this in your head. I like to be sure and be nice and careful. Is 0 less than or equal to negative 1? No, it is actually greater than, so I'm going to write false, or F. No. Okay, so that was a no. Let's try, we could either do this point, 1, 0, or 1, negative 1. Either one. Any point, literally. You could do 0, negative 2. All of those work. Alright, so I'm going to go ahead and try this one. Negative 1, or 1, negative 1. Okay. And we're going to go negative 1. Let's see. Obviously, this should be true since this other, the point on the other side was false, but I'm just proving it. If you got to this point up here, I'm not going to force you to do this part because if that side is false, this must be true. Alright, so 2 minus 1 is negative 1 less than or equal to 1. True. Okay, so that is true. That means this side is the answer set. So we're going to go. Yeah, so you get to color. You could even get some colored pencils out if that sounds fun to you. And there you go. That is how we graph those. All right, the next one. See, we have 2 more examples. Graph y is greater than negative 2. All right, so what if we had y equals negative 2? We find y at negative 2. And that means we have, this is the line. Now I'm doing dotted. Do you know why? Because it's not inclusive. It's not or equal to. So there is my dotted line. And it's easier to pick the point on this. Is 0 right here greater than negative 2? Yes, it is. So here is the answer set to that one. Okay, you can go as high as you want, be as nice as you want. There we go. Not too hard. Kind of fun. Who doesn't like to scribble on their paper once in a while? There you go. Okay, so if we did that with y, let's try it with x. Now, why does it say, this stumped me for a second, graph the following on a rectangular coordinate system? Now, hopefully you guys are pausing, writing this out, or watching it, and then I need to see all of your graphs in your homework, okay? Or when you turn in your homework, I need to see your notes for 115, so you should be doing this. All right, graph the following on a rectangular coordinate system. The reason they wrote that is so that you don't just graph this on a number line, okay? So we're going to graph it on, this is a coordinate system, a rectangular coordinate system. All right, so where is x equal to 3? It's right here, okay? And again, it's not or equal to, it's non-inclusive. So I'm going to go ahead and graph like that. Okay, there we go. And now let's pick the point 0. Is 0 less than 3? Yes. So that means all of this is your graph. Okay. So that's it for the examples. The practice has 3 more that we want you to graph on graph paper. So your notes for lesson 115, including your practice, should have 1, 2, 3, 4, 5, 6, 7 total graphs that you get to practice. And then you go ahead and do the exercises. Okay, this wasn't too long of a video, so you are welcome for that. But I do want to see nice, neat graphs. Thank you.